Hi, I'm Joe Young. I'm just here to talk to you about the program files for running the temperature monitor. This is the I2C source file. It's acting as a library file. It has three functions in it. The first is a wait function, which waits on the SPI flag bit to be set, and then when it's set, it clears it. It's used here in the main function of the library. The first line enables the I2C, sends a start bit, calls the wait function, waits for it to know that it's received, writes the address of the slave, waits again, and then goes into this while loop where it waits for acknowledgement. When it gets the acknowledgement, it sends the enable receive, or it enables it to receive, waits again. Then this line stores the data received. It sends a NAC, and then the stop bit is sent. Again, it waits for the SPI flag bit to be set again, and then just returns the data back. And here's just an initial startup for starting up the I2C setup. That's setting the baud rate and giving the flag bits their initial 0. This is just a header file of the functions involved in the library. And then here's where the entire program put together. We can see at the top here that the I2C header has been included. Just scroll down through the program here, we can see this is the main part of the program. It calls the initial, it starts up sequence, it tests the LCD to see that it's working correctly, and then it enters the main while loop, which displays the value on the LCD screen. That's pretty much that, and there's just the initial setup for the ports for the LCD operation. That's about it.
Yes, I'm Patrick Sheridan, and I'm just going to talk about the ADT75, the construction of it. Here we have the ADT75 sensor, which is mounted onto a solid onto a bracket board, which is then constructed onto a breadboard with the rest of the circuitry around here. Pins A0, A1 and A2, which are here, are wired to ground, which sets up the address 0x48 for the chip. Pins 1, 2 and 3 are pulled to VDD through 10 kilo resistors. Pin 1 is then connected to the serial data address, which is connected to pin 4 on the I2C interface, and pin 2, which is the serial clock line, which is connected to pin 3 on the I2C interface. The capacitor here is just used for decoupling the supply, and that code is running now, so we should be able to see the temperature changing when I put my finger on the chip. You can see it rising from 23 to 27 there now. So that part of the program worked well, so it did. So that's basically the construction of the ADT75. Thank you for listening.